All right, so the big ideas for today in the first lesson, but the second half of it is all about using algebra to generalize patterns. So we started off with these ideas of how do you subtract an integer and how is division related to multiplication. So the big relationship between addition and subtraction for integers is that 4 minus 9 is the same exact thing as 4 plus negative 9. So in general, to subtract an integer, you add the opposite. So let's think of it with money. If I had 4 euros and I wanted to spend 9 euros, I don't have enough money. I would have to borrow 5 euros. That's the same exact thing as having a debt of 9 euros and then you have 4 euros in your pocket. If you pay off 4 euros of your debt, you still owe 5 euros. So these are absolutely the same thing. A positive 4 minus a positive 9 is the same thing as a positive 4 plus the opposite of 9, a negative 9. And this division problem, 2 divided by 5, I know it looks like a fraction, and it is a fraction. 2/5 means 2 divided by 5. So another way to look at it is I have a candy bar, and I've shaded 2 parts of the candy bar. That's 2/5 of the candy bar. So it's also 2 groups of a fifth. So multiplication and division are related when I have 2 divided by 5. It's 2 groups of 1/5, and that's the multiplication part. So in general, to subtract an integer, you add the opposite. And we can write this with variables. We can say for, in general, for a minus b, that's equal to a plus the opposite of b. And for multiplication, we can also say for any two real numbers, a divided by b, as long as b is not 0, because we can never divide by 0, that's undefined, we can say that a over b, that fraction or that division problem, is the same thing as a groups of 1 over b, just like the candy bar. And then you tried some and practiced some. Page 7 in your book shows you these rules. You also can get them from the Smartboard lesson though. So 5/12 is a division problem. It's also, if I took a candy bar and divided it into 12 equal parts, 5/12 is 5 groups of 1/12. 1/12 would be each one of those parts if I split it into 12 equal parts. So 5 divided by 12, 5/12 is the same thing as 5 times a 12. And 12 minus 17 is the same thing as 12 plus a negative 17. They're both negative 5. Think about it with money and it makes sense. We practice with your scientific calculator, and we did this last class too, and you guys all know how to use the x squared key. It's a fast way to square a number. And then we practiced again with the exponent key. So if I wanted 5 to the third power, I do 5 and I use that key, 3, and that will give me the answer to 5 times 5 times 5, which is 125. And then you practice with the exponent key doing 12 to the fourth power. And I checked your calculators, you all did it correctly. So the second function key on your calculator, there actually is a little button that says second, and what it allows is each button to have 2 different things that it can do. So the x squared button, if you just press that, squares a number, but if you hit the second function key with x squared, it gives you the square root of a number, and that's actually written above the x squared key, and the color of this symbol matches the color of the second function key on most of your calculators, which is a hint that they go together. So squaring a number and square rooting it undo each other. So you guys did it with the second function of x squared, put in 625 and it gave you 25. If you hit x squared, it will take you back to 625. So we practiced that today as well. Okay, and then we did this guided example. So you have this big variable expression here, and there are brackets, and there's a division problem in the brackets, and within the division problem, there's subtraction and addition. So in step by step, remember, this is all in PEMDAS or GEDMAS, whichever, please excuse my dear Aunt Sally, this is one giant grouping that you have to do before you do your exponent. So the first thing was to substitute 21 for n and a half for w. So you rewrite it, substituting those values. Then this division bar is also a grouping symbol. So you subtract to get 6 3/10 on top. You add on the bottom to get 21.5. Before you use this exponent key, first thing you need to do is do the division and find out this answer. And then after you find this answer, do the division, 6 3/10 divided by 21.5, and then press equals, and you'll have the answer to that, and then you can use your exponent key to the third power. And you got a long number, 0.025, and it went on and on and on. And when it's that long, we can just round it off to the nearest hundredth. And because this is a 5, remember that we would say that 0.025 is closer to 0.03 or 300ths on a number line. So then you would give the wiggly equal sign, which means the answer is about 300ths, and that would be good enough. And then I showed you actually a clear rectangular prism and put some cubes on it. So we talked about why the volume of this cube, the number of cubes I can pour into it, is length times width times height. Well, when you do length times width, it tells you how many cubes are in the bottom layer. And then I have 15 layers of that. And I could stand this up so it was tall, and I'd have 15 times 20 in the bottom layer, and it would be 10 centimeters tall. So the big idea here was to generalize that it doesn't matter whether I group together 20 times 10 and then have 15 layers of that, or 15 times 20 and 10 layers of that. This prism is going to hold the same volume no matter which way I stand it up. And that led us to a basic truth about mathematics called the associative property of multiplication. And basically all it says is it doesn't matter when I have a multiplication problem how I group the two numbers I multiply first. I can multiply 20 times 10 first, put that in brackets, and get 200 times 15 is 3,000. Or I can multiply the 15 times 20 first, get 300, and 300 times 10 is 3,000. So the grouping doesn't matter. Notice I've not changed the order. 15, 20, 10, 15, 20, 10. So the order is the same, but I'm just grouping the numbers that I multiply first differently, and it won't change the product. It's always the same. And we talked about what other operation this is true for, and it's addition. It doesn't matter with addition whether I add the 5 and 3 and get 8 first, and then add 6 and get 14, or group together the 3 and 6 first, like I did here, and 9 and 5 is 14. So there's the associative property of addition as well. And it's just, remember, associative is like the word association, which as Tyne said means a group. We talked about an association of electricians, for example, and that's a group. So the grouping has to do with these brackets. When you move those brackets, you change the groups. So that's the associative property. And then another important property in algebra is the transitive property of equality. So we just took a real life example, and I said if Tyne is 13 and Shadia is the same age as Tyne, then Shadia is also 13. I put in 14 but found out you're both 13. So with numbers, it's the same exact thing. And as James said, this is just common sense. If 2 minus 5 is equal to 2 plus a negative 5, and 2 plus a negative 5 is negative 3, then 2 minus 5 is also equal to negative 3. So that's called the transitive property of equality. So here's an example we tried. If a half is equal to 50% and 50% is equal to 4/8, then what can you conclude? And you guys got it. You conclude that 1/2 is also equal to 4/8. So the first is equal to the last. It's kind of like if A equals B and B equals C, then A equals C in general terms. And we practiced some. This was the associative property of multiplication. And this was the transitive property of equality, and we could conclude that 63 225ths is also equal to 2800ths. And the beauty of knowing this is that most of the time we would use decimals, and all of these are 2800ths, which is the decimal 0.28. So for homework, you have two things to do: a little bit of algebra to practice. So on pages 11 and 12, this means you're going to do numbers 12, 13, and 14. The semicolon means skip to number 16 and do 16 and 17, and then skip to number 26 and do 26, 27, 28, and 29. So just a little bit of algebra work. Remember to fold your paper in half and work down your paper. And you have 1 hour in ALEKS. You got 20 minutes in class today, so just 40 more minutes. And make sure you also master 5 topics. So make sure you have both of those done and do the orange and green first. And that's it. Thanks.